Hello. This video is about the the capstone project, which was given to us to develop as part of the Google GenAI intensive 5-day program launched on the Kaggle. So I've developed a tool called AgilePulse, which is a data-driven LLM tool to streamline sprint reporting and analysis in agile software development. The intention is that we give a natural language interface to program manager or to project manager or a scrum master or anyone who has the access to their sprint dashboards. And using this natural language interface, they can query their sprints, their historical data of the various sprints, and they can get a sprint summary in an interactive way with visual representations of the sprints data, and also analyze the various data from the sprint. Something like a lot of things gets written in the sprint stories comments, and usually we don't look at insights from those comments. It can give us details about what are the different challenges which people are facing, which is getting recorded there in the comments, or if there is any good insight about the collaboration, if there is a positive thing about that, we can find that also. So there are various things like the positives and also the things which can be improved. So all of those insights can be found or can be queried using this tool. So that's the main intention using the Google GenAI LLM model 1.700. This tool has been developed, and I'll be using ChromaDB for storing the embeddings. So I'll be using a RAG model for this tool. So let's go through the quick walkthrough of what I have done. Of course, initially the setup is there. I'm just cross-checking the version, and then loading the Google API from the secret store, and then there is a retry policy defined to do the retries when there is a quota limit and all. And let's look at the function, the embedding functions from here. So yeah, I think this function has been referred from the 5-day program. Referred from there. So this Gemini embedding function has two modes: retrieval document and retrieval query. One gets used for document embedding generation, and another gets used for the embedding of the query. It is using the model text embedding 004 and to generate the embeddings here. Then here I have taken a dump of a dummy sprint data. Of course, we can make an API call in real time to fetch all the data from the tools like Jira or any other project management tool. Here, for the sake of the simplicity, I have taken JSON payload, which represents 5 sprint data. It has the sprint ID, sprint story IDs, then status of the stories, the comments within that, which developer is assigned to, and what is the story point. So these are the stuff which is part of this data, and there is a feature marking also that this story belongs to which feature. So here, once this data is loaded, we do a quick data lookup, and in fact, let me just execute this thing so that we can even see this in live action. Yeah. Yeah, so here the function is defined, and then we loaded this data. Do a quick lookup of this data. Yeah, so as you can see here, we have the um, like author of the comment. So this is comment wise data. We have the timestamp, we have comment, we have a sprint ID, we have the story ID, with which feature the and who is assigned this story, and what is the status and how many points it is. Then the next function, which generate an enriched document. So here I'm doing a grouping by the story ID and the feature, and yeah, I'm just collecting the status, collecting the story points, then developer wise story points aggregation, then feature level story points aggregations, and all of these comments I'm grouping in a single line, and I'm calling it as all comments. I'm just creating a blocker node. So in the comments, if I find something like delay, blocker, or issues, I'm adding it with the unfaced blockers or delays. And if it is collaboration or a smooth, then I'm adding a comment like and was successful due to the good collaboration. So based on this data, I'm creating a summary with a sprint feature, number of the stories, number of the developers, total story points, blocker note, and this is a structured summary which is creating. And then finally I'm creating this document object created, which is having its own ID, document, metadata, and we'll see how we are using the metadata also. But metadata is having the sprint ID, feature, status, story points, and some aggregation like developer story points and feature story points, part of that sprint. So once this once this function is defined, then yeah, let's get this and yeah, next step is to create a ChromaDB client and a collection for this use case. So yeah, and while creating the collection, I'm passing this Gemini embedding function. Then let's do a quick data assertion of what all the docs, IDs, and metadata has been created, and let's add this into the ChromaDB using this client. Okay, once this is done, we can see there are 25 records which is inserted there. Let's do a quick validation of this embedding. So we'll query this ChromaDB client, and we'll pass our query like what caused the delay in a sprint 2, and so let's see what it retrieves. So yeah, it retrieves the details like matching contents related to sprint 2, and it has also fetched the comments log. So yeah, this looks like it is trying to fetch the similar content. Looks fine to me. Yeah, next step is to define a function to query the ChromaDB. So I've written a small helper function which is using the regex. It is trying to find out if this query is having a sprint number identified. If it is, then I will try to load all the embeddings related to that a sprint based on the querying the metadata. So that's why I was storing the metadata, and if there is no sprint detected, then we'll just do a direct similarity search on this one. So yeah, once this is defined, let's see if it is able to fetch it. So yeah, I'm able to get all the metadata since the sprint 3 was there, and let's do a quick validation of this. Yeah, this prints all the documents passages which is part of that document. And next step is to define the summarize sprint function, and yeah, so in this function I'm giving a prompt saying that you are an AI assistant analyzing a sprint agile sprint documentation based on the following sprint records. Extract a summary in a structured JSON format. So I'm instructing that you will extract all this information and then you give me the response in a specific JSON format, which is this: total stories, featured work down, statuses, developers, and blockers. So that's the prompt given, and it's for yeah, it's trying to guide it that respond in the JSON format. I'm here using the Gemini 2.0 Flash model with this prompt, and then fetching the data. And once it gets this JSON data, I'm just trying to calculate the total story point from metadata and so on, developer wise aggregation and so on, and getting this. So this is the whole summary function, which will summarize me the sprint data. Let's do a quick check of this summary. So yeah, based on this, I'm able to get this total stories and feature work down. So all these features like card and checkout identity. And so this, the example of the data which I've taken is an e-commerce application development. So that's why like these features like card and checkout identity and access management, order management, payment integration, payment cataloging, and so on, then a status, and yeah, various details are here. And let's visualize this data. So I've written a helper function to visualize that. We'll see that. So let's see the visual representation of this data. Yeah, so we can see that feature wise stories points distribution, then developers wise stories point distribution, then the different status wise points status wise stories status distribution, and then what are the different blockers which were identified from the comments. As we can say, blocked by another story, awaiting design approval, dependency on backend API, environment deployment failed, and so on. And now let's look at the next step. So using the RAG based like what we just did is based on the RAG. So we are going to use this RAG based chat client with function call. So this is another GenAI feature which you want to show here. I've defined a tool called query similar document which will use the function which we defined above. Here the instruction giver is you are a helpful assistant for agile teams analyzing a sprint performance that can interact with ChromaDB for finding similar content. You will take the user's questions, query the ChromaDB to find the matching documents. Use query similar document function to fetch similar content or for questions from ChromaDB and answer the user's questions using the data returned. So yeah, this instruction is passed and it will use this function to get the data. Once it gets the data, then it will answer based on the data. So let's try some questions like how many features are not ready to go to prod in sprint 5. Yeah, and here we are. So it finds the answer and it identifies that these are the features which are having some of the other blockers, contains blocked stories, contains blocked to do and stories and so on, are still in progress. So there are 5 features which is not ready to go to productions. Yeah, so similarly we have another set of questions and I'm able to get almost accurate answers from them. So that's what I want to show from this tool, and I believe there is lot of enhancement which can be done, like we can ingest requirement document or budget information and so on related to the project management, all of the other content like from the Confluence document and so on, and we can make it more feature rich, and it can become like a natural language based interface which anyone can query and find more insight than just waiting for a monthly or a weekly reports. Right, so yeah, that's all from my end, and I'm happy to be part of this Kaggle capstone project. Thank you.